Hello guys, welcome to my new channel, Medicinal Pharma Education. In the previous videos, we have completed the introduction, theory, laws, and instrumentation is also completed. Next, we'll go to the next topic, choice of solvent or solvent effect, and the applications of the UV visible spectroscopy. In next video, we'll complete the chapter and one more topic which is not included in your portion but it is asked in the exam. It is Woodward-Fisher rule. It's also a very important topic as they've asked many questions in the examination Woodward rules. So this is the important question. By tomorrow we'll complete by the next video we'll complete the Woodward-Fisher rules. Okay, firstly we'll know the basic knowledge about the spectral shift, what is the spectral shift, and the effect of solvent polarity on various types of bands. Next we'll discuss about the choice of solvent and solvent effect, what is the solvent effects, and we will discuss the basic topics like chromosomes and acrosomes. These are the basic concepts we'll discuss in today's class. Firstly, we will discuss what is meant by spectral shift. Spectral shift is nothing but it is not important for exam point of view, but in Viva or for the knowledge purpose you have to study this. They may ask or not, but it is included in their portion in the UV spectroscopy. These are the topics included. We'll start with the definition. Spectral shift is a change in the position or intensity of absorption bands in the UV visible spectrum caused due to change in the molecular configuration, molecular electronic configuration. That's the basic concept. It tells that spectral shift is nothing but change in the position or the intensity of absorption bands, in the UV spectrum caused due to the molecular electronic configuration. This is the basic definition of the spectral shift. You don't want to go in the depth, just understand the definition. And next, the effect of solvent polarity on various type of bands. You know, right? Solvent polarity, uh, if the polarity, it means non-polar or polar, how it affects the solvent, on how it affects the various bands. Here K band the effect of the solvent polarity on K band is that the conjugated enes and ions are affected differently by changing in the polarity of the solvent. In the K band, the conjugated dienes are not affected by changing the polarity of the solvent, while ions show a red shift by increasing the polarity of the solvent. Here red shift is nothing but longer wavelength. Next, R shift is nothing but absorption shift to a shorter wavelength, blue shift, by increasing the polarity of the solvent. You just know the what are the effects, how the effect is on the bands. Just don't need to go in the depth, it is not important, just for your knowledge purpose I'm just giving this information. In B band, the increase in the polarity of the solvent is not shifted, but in heterocyclic organic heterocyclic aromatic compounds a marked chromic shift is observed by increasing the polarity of the solvent. These are the some topics not important. Next, the important topic is choice of solvent. The absorption bands in ultraviolet spectrum are very broad as compared in infrared or NMR spectrum. By this line we understood that the absorption bands in ultraviolet are very broad as compared to infrared and NMR. Next, the ultraviolet spectrum of the compounds are usually determined either in the vapor phase or in very dilute solutions. See, in ultraviolet spectrum, compounds are analyzed or determined in vapor phase or very dilute solutions. You know that in our samples which we use are very diluted solutions, not diluted solutions to analyze in the ultraviolet spectrum. Solvent must be transparent with in the wavelength range being examined. Okay, the solvent should be transparent. It should not absorb the wavelength range being examined. Next, a solvent of the UV spectroscopy should meet the following requirements. These are the requirements it should follow. Mainly, these are the requirements. It should not itself absorb the radiation in the region under investigation. It should not absorb the radiation in the region under investigation. Next, it should be less polar to minimize interactions with the solute molecules. Next, I don't need to explain, these are very simple lines. You can directly understand after you read once. The most common use of solvent is 90% ethanol. It is cheap one, good dissolving power, and does not absorb radiation above 210 nanometer. And some other solvents which are transparent about 210 nanometer are given by N-hexane, cyclohexane, methanol, water, and ether. See, the UV region starts from 200 to 10 nanometer. So these are the like solvents used in the UV visible spectroscopy, and the choice of solvent is based upon the selection of uh, the radiation which is above 210 nanometer, where the radiation is not absorbed by the solvent. This is the concept in the choice of solvent. Next, important topic, solvent effect. In that solvent effect, we study about solvatochromism. Solvatochromism, it is ability of a chemical substance to change color due to change in the solvent polarity. See, as the polarity changes, the color changes. That's the solvatochromism. Chromism means inducing of the color to the solvent. Change in the solvent polarity induces the color. Next, the science of solvatochromism depends upon the differences in the dipole moment of the ground state and the excited state of the chromophore. See, uh, the sign of the solvatochromism depends upon the difference in the dipole moment of the ground state and the excited state of the chromophores. Chromophore is nothing but the ability of the compound to generate the color. Next, the presence of specific and non-specific interactions between the solvent and the solute molecule are responsible for the change in the molecular geometry, electronic structure, and the dipole moment of the solute. See, if the solvent and solute react specifically or non-specifically, interactions causes the change in the molecular geometry, electronic structure, and the dipole moment of the solute. Here the solute and the solvent are interacting, both are interacting. These are the changes causes after the interaction of the solute and the solvent. Next, the solute and solvent interaction affects the solute electronic absorption spectrum. This phenomenon is known as solvatochromism. See, as the solute and solvent interacts, right, there will be change in the, what are the changes? There will be change in the molecular geometry, electronic structures, and dipole moment of the solute. As these interactions occur, there will be an effect in the electronic absorption spectrum, and the electronic absorption spectrum means that the change in the absorbability of the solute or the sample, and the results are deviated from the true values. These are the deviated values after the interactions of the solvent and solute. This phenomenon is known as solvatochromism. Mainly, and you have to understand the two basic topics involved in the UV spectrum in the solvatochromism are chromophores. Huh. A chromophore was considered a system responsible for imparting or developing color to the compound. I think so. I understood. A chromophore is a material which is responsible with a material or a system responsible for importing or developing color to the compound. Okay. Example: nitro groups are yellow color. You know that nitro groups are yellow color. These acts as the chromophore. Definition: as any isolated covalently bonded group that shows a characteristic absorption of UV or visible region. I think so I understood. It is an isolated covalent bonded group that shows and characteristics absorption in the UV and visible regions. There are mainly types of chromophores. There are mainly two types: chromophore containing pi bond under grouping N to pi bond transition. Example: methylene and acetylene. And chromophores containing both pi electrons and n type n electrons under and undergoing pi to pi transition, pi to pi transition, and n to pi transition. I think so is pi to pi star and n to pi star transition. Next example: carbonyl, nitriles, azo compounds, and nitro groups. You just remember the definition. The types are not that much important. In exam they ask the definition and an example, that's it. And next one is next the oxochromes. And sorry for mispronunciation, I don't know how to pronounce. So I pronounce it oxochromes. You can search in the Google. An oxochrome group can be defined as a group which does not itself acts as a chromophore, but whose present shifts of the absorption band towards the red end of the spectrum, longer wavelength. Already I said the red shift is nothing but longer wavelength. Here axochrome's presence does not directly itself act as the chromophore, but whose presence shifts shifts of absorption band towards the red end of the spectrum. I think so you understood. Mm. The absorption at a longer wavelength is due to the combination of chromophores and an axochrome to rise to another chromophore. This is called as color enhancing group. Okay, see, it's a basic concept where it is the combination. The absorption at longer wavelength is due to the combination of chromophore and axochromes to give which gives rise to another chromophore. I think so I understood. The combination of these two will get another chromophore. This is called as color enhancing group. The examples are uh, hydroxyl group, OR group, NH2 group, NHR group, and RNN2 group, and SH group. These are the examples which are also called as color enhancing group. This is the basic concept of the chromophores and uh, ag, uh, acrochromes. Sorry for mispronunciation. Okay, this is the basic concept. In the next video we will complete the UV visible spectroscopy, and you can see the notes. You can just see the notes, copy the notes. If you want, you can read these topics, or you can leave it. And the important topics are these topics. You should know these topics because it is directly related to the a practical point of view, the choice of solvent and etc. and examples. See, these are the examples of the solvent. This is the solvent effect. Next the solvent effect. Chromophores, their types, and acrochromes. I think so I have pronounced correctly. Thank you guys for watching this video. like and comment if I have made any mistakes. I'll correct in my next videos. Thank you guys. Bye. See you in the next video. Have a great day.